So today we're going to learn about ellipse, and you can go to page 101. There's a picture and some definitions, but I'm going to draw out a picture, and hopefully that will help you guys. So I'd grab some colors, pause the video for a second, and let's draw out our ellipse. So somewhere in space I can have an ellipse. It can be vertical or horizontal. I'm going to draw my ellipse. So on my ellipse, there is a center. Let's use some colors today. We'll do this. This is my center. And there are these 2 points called the foci, because they're one on the parabola there was a focus, but because there's 2 of them we call them foci. The foci is where things gather. We have 2 things outside the foci. These are called the vertices. And then we have 2 things that go up and down. These 2 things are called the co-vertices. And they don't always go up and down. They're just always opposite the vertices. Okay, so now let's talk about some... I'm going to run out of colors. Let's see. Let's grab another color. Let's try... Let's do purple. So, a ellipse has a thing called a major axis, and the major axis is going to go from vertice through the foci, through the center, all the way to the other vertice. So vertice to vertice is called the major axis. And then I'm gonna grab, let's see if I can get an orange maybe. From co-vertice through the center to the other co-vertice. So co-vertice to co-vertice is called the minor axis. And I'm going to go in here and label some lengths. So from, I don't want to use white. Hang on, let me grab one more color. Let's see, what have I not used? Use this light pink. So from a vertice to a center is called length A. From a center to the other vertice is called A. So the length of the major axis is always 2A. A co-vertice to the center is B, and then center to a co-vertice is B. So the length of the minor axis is 2B. The last length we have is this one right here from the center to the foci, and this length is called C. Now I've drawn this parabola horizontally, but if we were to flip it vertically, everything would stay the same. It's just that the vertices would go up and down instead of left and right. So now I'm going to move to page 102, and we're going to talk about 2 formulas that we're going to use for ellipse. Okay, so we have the formula x minus h squared over a squared plus y minus k squared over b squared equals 1. So h and k are the center, and a and b are from the previous screen or previous slide. A is the distance from the center to a vertice. And B is from the distance from the center to a covertice. One thing we need to note, this A is always bigger than B. The distance from my center to my vertice will always be bigger than the distance from my center to my covertice because the vertices are always farther away. And because of this fact right here, wherever the A is, it tells you which way it goes. So because A, oops, sorry. So right here, A is bigger than B always. A is with X stuff. So and this little symbol means therefore. This is a sideways ellipse. Or side to side, a horizontal. Because the big thing is with the X stuff. But what we also can look at is, let me shrink this down for you. Put that up in the corner. I have another equation for an ellipse. It looks like this. It says x minus h squared, and it has my y minus k squared. But this time the b squared's under the x stuff and the a squared's under the y stuff. And right here, a is bigger than b. Therefore, this is a vertical or an up and down ellipse. So you're just looking to see where's the bigger number. Is the bigger number under the x stuff or under the y stuff? So with that in mind, we're going to go ahead and move to the 3 example problems on page 103. Before we do this example, I'm going to review 2 rules that we have. If you follow these rules, it will negate a lot of issues. 1, draw it. Draw what you're given. 2, shape and orientation, meaning which way does it go, which then leads you to your equation. Because if you have the wrong shape or the wrong orientation, you're going to grab the wrong formula. So it says find the standard form of the equation of an ellipse having foci. So let's draw this. Hang on, let me draw. So I have a foci at 0, 1. I'm going to label it with an F to remember what it was. And 4, 1. So 1, 2, 3, 4. Okay, and they tell me that my major axis has a length of 6. We have to remember that's 2. Oops, hang on. That's not what I meant to write. I'm going to try that one more time. We have to remember that's equal to 2a, because my major axis is 2a. It tells me that my center is at 2, 1. And they didn't even have to tell us this, because halfway between the 2 foci, you can find the center. They tell me a is equal to 3, which we could have done the math right here and found it as well. And they tell me that b is equal to the square root of 5. So it wants me to write the equation in standard form. So to write an equation, I'm going to shrink down what I have really quick. To write an equation, we have to know a couple things. Before we can do that, we need to do the shape and the orientation. Well, this definitely tells me that, 1, I'm an ellipse. I wish I could write today, guys. I'm really sorry. Let's try that one more time. And number 2, because my foci are going sideways, my vertices are going to go sideways too, because remember the foci and the center and the vertices all are on a straight line together. So I'm an ellipse, and I am sideways or horizontal. Okay, so let's use what they told us. A is 3. So if we wanted to finish drawing this, we could. 1, 2, 3. This would have been a vertice. And then 1, 2, 3. This would have been my other vertice. And b is the square root of 5, which isn't a very pretty number, so I'm gonna leave it alone. But because we know we're in an ellipse and we're sideways, we're using this equation, x minus h squared plus y minus k squared. And because it's sideways, the a squared goes under the x stuff, and the b squared goes under the y stuff, and it equals 1. And now all we have to do is plug stuff in. We're just gonna write down what we got going on. So my hk is my center. And they told me that my center was 2, 1. My a is equal to 3. My b is equal to the square root of 5. And now I can just plug this in. So I'm going to have x minus 2 squared plus y minus 1 squared. A is 3. 3 squared is 9. B is square root of 5. Square root of 5 squared is 5 equals 1. This is your answer for this problem. Not horrible. We got this. Let's try another one. The next one says that I'm going to sketch a graph of an ellipse, but this time I'm in what's called general form. In the last problem, our equation was in standard form, but when we write things like this, x squared plus 4y squared plus 6x minus 8y plus 9 equals 0, this is called general form. So when we did the circles, we regrouped things, and then we completed the square twice. And I'm going to do the same thing here. So the first we need to do is we need to move this constant term over. So we're going to have x squared, and when I do that, I'm going to put my stuff together. Plus my 6x, plus my 4y squared, minus my 8y, equals a negative 9 that I've moved to the other side. I'm going to complete the square for my x stuff. X squared plus 6x plus a blank. For the y stuff, you have to be careful. You got to pull out a 4. So plus 4 y squared minus 2y plus blank equals negative 9. So this is b over 2 squared, and my b in this case is my 6. So 6 divided by 2 is 3. 3 squared is 9. Then over here, if you write plus 9. And then this is my b. It's negative 2. Negative 2 divided by 2 is negative 1. Squared is 1. Be careful. They have to bounce. So you have to add a 4 to the other side. Because you didn't really add a 1. You added a 1 times a 4. This is now going to force the x stuff to factor into x plus 3 squared plus 4. And then my y stuff is going to factor into y minus 1 squared equals 4. The ellipse, and you'll find out later this week, the hyperbola, they always equal 1. So we're going to divide everything here by a 4. Make things a little bit smaller. And so when I divide everything by the 4, I'm going to have x plus 3 squared over 4. 4 divided by 4 is 1, plus y minus 1 squared over 1 equals 1. So now we can draw our pretty graph. So let's make this happen. Let's see. This is purple, draw purple. So this and this is my center. So it was supposed to be a minus, but it's not, it's a plus. So my center is negative 3, 1. So I'm going to go draw my center at negative 3, 1. So 1, 2, 3, and down 1. There's my center. This right here was my, this is my bigger number, so this must be my a squared. So when I square root that, a must equal 2. So from your center, you're going to go sideways, 2 dots. 1, 2, that's going to be a vertice, and then 1, 2, vertice. Again, the reason I knew to go side to side is because the bigger number was under the x stuff. If the bigger number were under the y stuff, then I would have gone up and down that 2. This is going to be my b squared. So the square root of 1 is 1, so b equals 1. So I'm going to go up and down 1 for my covertices. This is going to be the smallest little ellipse ever. There's my ellipse right there. Okay, one more problem. So in the next problem, we don't have to draw anything, but we have to do the same process to find stuff. So let's do this. So this problem, number 3 on page 103, says that I have 4x squared plus a y squared minus an 8x plus a 4y minus an 8 equals 0. I'm going to move this 8 to the other side, and I'm going to regroup. So 4x squared minus an 8x plus y squared plus a 4y equals an 8. Pull my 4 out of my x stuff, so 4x squared minus 2x plus blank, plus, there's no number in front of my y squared, so y squared plus 4y plus blank equals my 8 plus something plus something. Negative 2 divided by 2 is negative 1. Negative 1 squared is 1, but we have to be careful and bounce it, so we have the 4 out front. So 4 times 1 is a 4. On the y stuff, I don't have anything to bounce. 4 divided by 2 is 2. 2 squared is 4. And then this becomes another 4 that I added. So my x stuff is going to be 4. And then it factors into x minus 1 squared plus y plus 2 squared equals 16. Remember, ellipses and hyperbolas have to equal 1. So I'm going to divide everything by my 16. And you're going to get x minus 1 squared over 4 plus y plus 2 squared over 16 equals 1. That equation is kind of going to be our key to everything. So we need this thing. We're going to need this to find everything. So start with my center, because it says it wants you to find the center, vertices, and foci. So my center is going to be 1 comma negative 2. It's my h and my k right there. This is smaller, so this is my b squared. So that means b equals 2. This is my a squared, so a equals 4. And because my bigger number is under my y stuff, this is going to go up and down. So if I want to find my vertices, I'm going to go up and down 4 from the center. And if you're going up and down 4 from the center, we're not changing the x value, we're changing the y value. So to find my vertices, you take your center, 1 comma negative 2, and we're going to move up and down plus or minus the a value 4. And I'm doing that to the y part because it's up and down. If this were a side-to-side ellipse, I would do plus or minus 4 to the x piece. So my vertices are going to be 1 comma negative 6 and 1 comma 2. To find my foci, I need to know c. And this is where this very important formula comes in. So you got to know this formula. It looks almost like Pythagorean theorem. It says that c squared equals a squared minus b squared. It has a minus in it, and the way that I remember it is that my ellipse equation has this plus sign in the middle. And so the plus sign's there, so my c formula has a minus sign in it. And this will make more sense on Thursday when you do hyperbolas. But I'm going to use this formula, and I'm going to say c squared equals a squared, which is 16, minus my b squared, which was 4. So c squared equals 12. So c equals square root of 12, which is going to be square root of 4 times the square root of 3. So c equals 2 root 3. So my c, remember, is the same way, like, let me draw really quick for you. If this is my center, and since this ellipse goes up and down, I'll go up and down. But if these are my vertices, then my foci are going to go up and down as well. So for my foci, I'm going to start at my center, 1 comma negative 2, and I'm going to go plus and minus 2 root 3. I'm just going to leave my answer like that because I can't simplify it. So there's the answer for my foci, which the question asked us for. Here's the answer for my vertices that the problem asked us for. And here's the answer for the center that this problem asked us for. So now you can go back to Canvas and you can do your practice on ellipse for this week.